start talking about biconditionals, and that's the last section in the chapter that before the quiz. So we're going to have a quiz on Tuesday that starts with inductive reasoning and goes through biconditional statements that we're doing today. It's Tuesday. All right, so let's get to biconditionals. Oh, and I printed out on the website are all the words that you need to have in your flashcards. And those flashcards need to be done by Monday, because if they're not done by Monday, then you won't be able to use them for the quiz. So they need to be finished by Monday. All right. So biconditional statements. I'm sorry?
So did you say
Flashcards on Monday.
no, it is study inductive reasoning
To biconditional, yes. 2-1 through 2-4. All right. A biconditional statement occurs when the conditional and its converse are both true. Okay? Bless you. So, if you can read it forwards and backwards, then it's a biconditional statement. Can someone think of one? Can someone think of an if-then statement that would work forwards and backwards? So the conditional and the converse are true? Just anything. Can I think of one? Oh, come on. You can pick one. Okay. So biconditional statements work forwards and backwards. The symbol, because it means if P then Q, and if Q then P, they're both true. The way we write that is with an arrow that goes both ways, like a line symbol. Okay, because that means if P then Q, and if Q then P. So when you see that, that's indicating a biconditional statement. Okay? So I make sure I jotted that down. So if, like, the test question was, what's the symbol for a biconditional statement, you could write that. All right? Yes? Oh, here. Okay? So an example would be, and then the other thing that you need to know is instead of, up until now, we've just always been doing if-then, like an if-then statement. Well, in biconditional, because the if, the hypothesis could be the first one or the second one, and the conclusion could be the first one or the second one. Instead of if-then, we use this if and only if. Okay? And you know how mathematicians hate to write things out. They always love to simplify things. So instead of writing if and only if, they write IF. And that means if and only if. Okay, so this statement, a number is odd if and only if it is one more than a multiple of 2. Well, for that to be a biconditional statement, I would have to be able to prove that the conditional is true and the converse. So if a number is odd, then it's one more than a multiple of 2. Is that true? Think about, give me a multiple of 2. 6. What's one more than that? 7. Give me another multiple of 2. 10. One more than that? 11. Are those all odd? Can you think of a time it wouldn't work? No. So that's true. If a number is odd, then it is one more than a multiple of 2. And if it is one more than a multiple of 2, then the number is odd. Does that also work? Yeah, that also works. So that's why we can write it as a biconditional statement with the if and only if. Okay? I think of the if and only if as sort of like the center of a swinging door. So it has to be right at the center so it can swing this way or this way, because you can read the biconditional either way. That's why, like, if it were if and then, it would cement it down in one order. But because that's in the middle, it can switch. That's why you have to write it like that. All right. So let's tear apart a biconditional, just make sure we know all the parts and we can write them. In this statement, 2 angles are congruent if and only if their measures are equal, what is the hypothesis?
Could it be either of them?
Yeah, so pick one.
Their measures are equal.
Good. Their measures are equal. And what Brittany just said is exactly right. She picked their measures are equal to be the hypothesis, but couldn't you also have picked two angles are congruent to be the hypothesis? Right? Because it's a biconditional, so it doesn't matter. But once you pick it, then what's the conclusion for this one? Yeah, it has to be that two angles are congruent. Okay? All right, so then what's the conditional? If that's my hypothesis, that's my conclusion, what's the conditional? How do you want to try it? Just the conditional, if then. Actually, that can be true, but since we already started off in this order, let's just keep it going in that order. So, if, right, if their measures are equal, then the two angles are congruent, right? So the way he said it isn't wrong. It's just that since we started out that way, we're just going to finish it that way. And then the converse would be Adam? Right. That was a question right off your chapter 1 test, right? Remember that one? Angles are congruent and the measures of them are equal. So if two angles are congruent, then the measures are equal. Good. Okay? So take a second and write down the hypothesis, conclusion, conditional, and converse of this one. Solution. Okay? And the conditional then would be, Becky? Oh my gosh, what is the deal here? Okay, if you switch the hypothesis and conclusion, this would be your conditional. So if the solution is a base, then pH is greater than 7, which doesn't exactly match our hypothesis and conclusion, but it is a conditional. And what would the converse be? Right. Okay, now let's try doing it the other way. If I give you the conditional, let's practice writing the biconditional. Okay, so I think that the easiest way is first to write the converse. So what's the converse of if the date is July 4th, then it's Independence Day?
If it is Independence Day, then the date is July 4th.
Right. If it's Independence Day, then it's July 4th. Okay? And so what would be the biconditional? That's the tricky part because you can't, remember, don't start with if. Getting it started is the kind of the tricky part. Sarah? Start with? Right. It's Independence Day. What comes in the middle? What goes in the middle of all of our biconditionals? What? And what does it stand for? Right. Good. it's Independence Day if and only if it's July 4th. Good. Okay, now, to test that, to be a biconditional, it has to be true both ways. So let's take it a piece at a time. If the date is July 4th, then it's Independence Day. Is that true? Careful, because we didn't say in the United States. Do you think they celebrate July 4th in England? No. Probably not. It's probably not a good day for that. So if it's July 4th, it's Independence Day. Is that true always? No, you could think of a counterexample, right? So that's false. How about the converse? If it's Independence Day, then it's July 4th.
True.
Yeah, that's true. They don't have an Independence Day. They never had to get one. Okay, so if the conditional is false and the converse is true, can the biconditional be true? No. No. They both have to be true for the biconditional to be true. It has to be true forward and backward. So that would be false. Okay? How about this one? If 2x plus 5 equals 11, then x equals 3. What's the converse of that, Gabby? Okay. Then 2x plus 5 equals 11. And what would the biconditional then be? Haley? Right. X equals 3 if and only if 2x plus 5 equals 11. All right, so let's test it and see if it works. If 2x plus 5 equals 11, then x equals 3. Is that true? Yeah. How about if x equals 3, then 2x plus 5 equals 11? So is the biconditional true? Yes, because the conditional and converse are true. So these are all going to be stacked up in a row or not at all. Okay? All right. Oh, and I wanted to show you, once in a while, instead of IFF, they'll put the biconditional symbol, that arrow thing in there too. So once in a while, you'll see it like that. Not very often, and I don't usually do it, but like if you're looking through a textbook or something, once in a while, you'll see that little symbol instead of IFF. Yeah.
With the IFF, if you ever read this statement, you say if and only if.
Yep.
Don't say IFF.
Yeah, it's to say if and only if, because that's what it stands for. All right, so let's do the application of biconditional statements is that that's the way you test to see if you have a good definition. Because if you look up a word in a dictionary, you get a definition, right? And if you look up that definition, don't you expect that word then to be with it? They have to be married together at all times. You can't expect a different word from the same definition, otherwise it's not a very good dictionary. So if you can write a definition as a biconditional statement, then it's a good definition. So let's practice. I have congruent angles are angles that have equal measures. How could I write that as a biconditional statement? Congruent angles are angles that have equal measures. Think about that for 1 second. Maybe even actually, why don't you jot it down? All right, who's got this one? Did you say you had it? Mike? Oh, you didn't. Oh, shoot, you did last one. Right, okay. I think I would do it the other way. A shape is a square because we're not proving that the square is a shape. We're proving that the shape is a square, right? See what I mean? So a shape is a square if and only if it has 4 equal sides. Okay, so let's test it. If a shape is a square, then it has 4 equal sides. True? Yep. How about if it has 4 equal sides, then it's a square? Counterexample? So that wouldn't have 4 equal sides. I'm sorry? Again, not 4 equal sides, but I think you're thinking of the right thing.
Rhombus?
Yeah, rhombus. Were you thinking of a rhombus? Yeah, it's a rhombus. Right. So rhombus would make that false. All right, question.
But if that one's, if the biconditional is true, it doesn't everything have to be true to make the biconditional true?
Yes. So this definition would not be a good one because it's not true. So you couldn't write this as a biconditional. You have to add some stuff to it or fix it. Okay. All right. So let's take a minute and you guys write a biconditional statement as a definition for